I'm from Melbourne, Australia, and have over a decade of research experience. I've always been attracted to using mathematics to understand complex problems. The more complex, the better. I've had research positions in astrophysics, chemistry, geophysics, and some work in molecular dynamics. I got interested in mathematics at a very early age from my father, who was an engineer. So whenever I asked him a question, he wouldn't make up some nice poetic story. He'd tell me actually what it was, and he'd describe it in mathematics. When I was a teenager, he lent me a book about chaos. For example, how a small change in the initial state of a system can create a huge difference in the final state. I found the images these generated actually quite beautiful, not just from the aesthetic point of view, but from the knowledge that all of that beauty came down from a very, very small equation. The feeling was expressed in some of my oil painting, particularly one shot where I actually had some galaxies colliding, and I put an equation in there as well. I think of mathematics as an elegant language that enables us to describe and understand very complex and very deep ideas. I first came to China because I wanted to live in a country that was rapidly rising. My first research position after finishing my Ph.D. in Australia was in the University of Barcelona in Spain. Coincidentally, at the end of 2008, which was during the global financial crisis. I saw a lot of parallels between the research I was doing and the socio-economic world at the time, in that a tiny push was all it took for a system to become chaotic. In this case, for example, a lot of the financial crisis was caused by subprime loans in the US, and that was able to basically destroy the Spanish economy. So afterwards, I became interested in human dynamics. So I decided that the next place I wanted to live was somewhere which was on the rise, as a symmetrical contrast from Spain, which I'd see fall. Naturally, I was drawn to China, first to Beijing and then to Shanghai. The area is much more manageable in Shanghai than it is in Beijing, although the winter can still be rough here. The scientist who most inspires me was Sir Isaac Newton. Firstly, he was a great scientist who was able to take the motions of the planets and derive a very simple equation that explains them all, and still applies to most cases in the universe. He also made huge contributions to optics, telescope design, and of course invented a lot of what we call calculus. His work in gravity is of special significance to me, as he was able to solve the two-body problem with an analytical solution, but failed to solve the three-body problem. An example of the two-body problem is the Earth going around the Sun. An example of the three-body problem is where you've got the Earth, the Sun, and then, say, Jupiter on the outside. Now, if Jupiter is too close, it disrupts the other orbits and the system becomes chaotic. And a lot of my research was how close this third body had to be to actually cause the system to become chaotic. Well, there are a combination of factors. Firstly, I wanted to do data science in an innovative and agile company in East Asia. My wife really wanted to come back to be close to family. Coincidentally, a mate of mine, Carlis, who works at MCON, contacted me and described what they were doing and what they planned to do, and it looked like it was good for a laugh. Luckily, it turned out to be a good fit, as it offered the opportunity to introduce data science and predictive analytics to an existing company and work on a wide range of projects and products, rather than focus on a single very narrow topic. Also, MCON is open to experimentation in terms of applying methods that I've used for analysing data in the natural world to more messy and sometimes just plain erratic customer data. The short version is that I basically come up with insights from the data to help our clients. Of course, this requires a lot of consultation with the clients to see what the data they've got and what tools, particularly big data tools, are actually applicable and what's possible. From a technical standpoint, I write a lot of R and Python scripts that must be as portable and robust as possible so that we can deploy them either on the client's on-site systems or using cloud architecture, typically AWS, as they are a business partner of ours. Right now, my major business focus is building statistical models to predict mechanical services, costs, damage patterns, and valuations as a function of mileage for every vehicle model. Recently, I've also been using data mining and machine learning classifiers to design target groups for marketing campaigns based on demographics and behavior. Interesting question. First, it's best to define what we mean by data science and by traditional business intelligence. From my point of view, data science is applying scientific thinking to messy data, often using big data tools. Whereas traditional BI is taking business data, typically from an on-site data warehouse, and applying basic statistical analysis, for example, averages and trends. Usually this was done using long SQL scripts that quickly became almost impossible for anybody to actually read and understand. Then the results from these SQL scripts, say a trend line, are extrapolated to the future to forecast sales. So the two main ways that data science is shaping predictive BI are firstly technical and secondly an influx of new ideas. From the technical side, new tools have improved statistical quality and paradoxically made it easier to actually do. For example, R, big data and cloud computing. From a more soft skills point of view, often data scientists have very different backgrounds to BI professionals, myself included, so there's been a large influx of new ideas. Personally, I see this as bringing more mathematical modelling or predictive analytics in business terminology into data analysis. I'm often struck by the similarities between seemingly completely different fields and the leaps that can be made by taking a technique that is well established in one field and applying it to a different field that no one had thought of doing before. Of course, humans aren't deterministic like the motions of planets that I'm used to dealing with, so something else is needed to fill in the gap. Such tools have only recently become available with the increasing computational speed and easy-to-use big data techniques, for example, AWS tools. My main project has been to perform predictive analytics for vehicle maintenance over the lifetime of all vehicles in Germany. From this, we can predict the likely costs against time or mileage and compare this to the value of the car. For example, your car might be 7 years old and have done 100,000 kilometres. We can predict from the data that in the next 6 months, there's a 10% chance of the timing belt failing, 5% chance of the disc brakes failing, etc. When you combine this with the price of each service, then you can estimate the cost of running your existing car for the next 6 months. At the same time, the market value of your car has been decreasing each year. This matters if you want to know when to trade in your car for a new one. So the point where the repayments for a new car are less than the service cost for running your current car is the ideal time to trade in. We can estimate this point from the data, which is very useful from a business perspective and of course when I want to buy my new car. From my other projects, I find it interesting to see what emerges from the data even without knowing all the driving forces behind the data, such as different purchasing behaviours in different countries and cultures. My main aim is to continue to apply mathematical modelling and big data techniques to understanding customer behaviour. We've only scratched the surface in terms of what machine learning and big data techniques can do with customer and real-time vehicle data. We then will use these methods to create a new range of predictive BI products for automotive and customer relations management generally. At MCON, we are currently organising our BI team to have more of a data-orientated mindset. So my objective in this direction is to provide coaching and experience, for example, running workshops on R and statistics. I believe 2018 will be a great year for us.